Now, one area where systems can be very useful, it's going to require for us a little bit of, again, what we call academic tenacity. We're going to kind of have to work through this a little bit. And if we do that, I want you to show you what we can do, better yet, what you can do to help you become a better navigator, a better consumer in the world that we live in. So let's use an example here, an example that I have. A friend of mine bought brand new property along the riverfront, maybe down on the Umpqua River. But he's got some houses squeezing in on the side of him, so he's wanting some privacy. So he's going to go down to Garrettson's and get some lumber and build a fence around it. Well, he wants on the front of it to look really nice. So he's going to spend a little bit more money on the front face of the fence, but on the sides, maybe not as much. So here's some information we know. We know that his lot, the perimeter of his lot is 1,000 feet. We know that the price of the front-facing fencing is $25 per foot. We know the fencing on the sides is $5 per foot. Don't really know what the dimensions of his whole yards are. And so I want to find out, well, how wide, how deep is his yard or is his property? And then afterwards, I want to find out, maybe I like the good looking fencing all the way around. If I have $16,000, which is my maximum budget, maybe I can put the good stuff all the way around. All right, that's a problem that we have before us. And I want to walk through how we can start to develop a system to give us a system to go from there. So the question's asking us, what is its length and what are its widths? Or what is its width and what are its lengths? So when we give it, or when we're provided an information that we don't know, we typically label that as some type of variable. So let's label this side as X. We know these two sides are the same length, but not necessarily the same as that. So let's label that a Y and that a Y. So let's start to build some equations, some things that we know to be true. Can we build a model to represent its perimeter? Well, the perimeter of this entire lot is all the sides added up. So that would be a 2x plus a 2y, and we know that equals 1,000 feet. I have one equation. Well, again, in order to solve this, we know that this particular equation has an infinite amount of solutions. But we need to find the one solution that matches all of this other information. So we need to have two equations to solve two unknowns. So can I develop another equation? What else do I know? Well, I know something about its cost. I know that he wants front-facing wood to be $25 per foot, and on the sides it's $5. So let's add that on up. Did I give one more piece of information? I did. And this budget was $9,500. Sorry, I forgot one other piece of information. So he's going to spend $9,500 on this existing plan. So that would equal, I have X length here. He wants 25 feet per X. And then over here, it's $5 per Y, and there's two Ys. So it's 5 times the two Ys equals the starting budget, which is $9,500, which I omitted earlier. So it looks like I have a system. So let's go ahead and give a little bit of a system notation. I'm going to rework it over here. 2x plus 2y equals 1,000. The other one is 25x plus 10y equals 9,500. Now, if I just gave you that, I think you can get us home from here. But the struggle in this section is just going to be working and practicing and starting to build this. And that's going to be a little difficult for us until we get used to it. And I understand that. All right. First thing we want to do is it's written in standard form. Maybe multiply the top by -5. So that's going to give me -10x minus 10y equals minus 5,000. That line is exactly the same. I can add now, and when I add these two together, it looks like the y's are eliminated. 15x equals 4,500. And then x equals 300. And then I get x equals 300. But I'm not done. What does that 300 mean? These are application problems. We're solving something because it wants to be meaningful. We want to be able to figure out what's going on. Well, we remembered that we set the length of the front part of his yard facing the road as x, and we found out this to be 300 feet. From there, we need to figure out, well, what is its dimensions over here? So let's plug in this value into one of these equations. And this one to me looks the easiest. So that would be 2x plus 2y equals 1,000. Substitute x in. 2 times 300 plus 2y equals 1,000. Solve. And I got y equals 200, which tells me that the depth of this lot is 200. And does that make sense? Does this fit it with a 1,000-foot perimeter? If this was 300 over here, 300, 3, yeah, it's 1,000 feet all around. So that makes sense. It makes sense with reality. And this is what he can build for $9,500 based on those requirements. The second part of the question he's curious about is, well, what if I up my budget up to $16,000? Am I able to put the good stuff all the way around? Well, now that we understand what all the dimensions are, we know that its dimensions are 200 plus 300 plus 200, which is 700. So he has 700 feet. Wants to multiply that by 25 feet. Yeah, how do I want to multiply that out there? And it looks like in order to put the good stuff, it's going to cost him 17,000 plus, 17,500 feet. So his budget is not able to accommodate that. So I hope this is helpful. This is a little bit of a step up from where we're at, but with practice, I think we all can do it, and I think you can do it as well.